Dear students, today we will go to hypothesis testing. Actually, when you are learning this hypothesis testing, there are some steps. Then those steps you have to learn. If you are learning the step-wise, hypothesis testing is very easy to learn. Then hypothesis testing, it is the process. It is the process of determining whether a hypothesis is supported by the results of a research project. Actually, there are two types of hypothesis, null hypothesis and alternative hypothesis. In earlier video we discussed. Actually, then we don't know which one is supported by the results of a research project, but one of it may get supported by the results of a research project. That is the thing we are going to do here in hypothesis testing. Sometimes null hypothesis may be the correct one, or otherwise alternative hypothesis may be the correct one. If the null hypothesis is correct, we are telling it is failed to reject null hypothesis. That means null hypothesis is correct. If we reject null hypothesis, if we accept alternative hypothesis, we reject null hypothesis. Then all the time we explain the hypothesis testing with the use of or by means of null hypothesis. We have to remember that. Actually, why we are doing this hypothesis testing? Actually, the population is very big. Then there are a large number of individuals in the population. Therefore, it is very difficult to analyze the population data. Then therefore, what we are doing, we are getting random sample from the population and we are checking the sample. Then sample is the experimental group. Then what we are doing, we are getting some particular conclusion about the population with the use of sample. Therefore, in statistics, draw inferences about population using sample gathered from the population. Then sample may tell something about the population when we are doing researches. Okay. Then that's the thing we need to understand why we are doing this hypothesis testing. It is very difficult to analyze the population data. Therefore, we are getting the sample out of the population. That sample should be the random sample. Then we are doing some inferences about population with the use of sample data. That's the thing we need to understand. Then what are the concept of hypothesis testing? The very first one, a statistical hypothesis is an assumption about the population parameter. Actually, we have to measure some population characteristic with the use of statistic. Then it is also hypothesis. We don't know whether it is correct or wrong. Then by doing the research, we are checking the particular title or particular research question is correct or wrong. Like that, we are checking that by doing some researches. Then therefore, a statistical hypothesis. Hypothesis mean what? Is an assumption. That is only assumption about the population parameter, whether it is true or wrong. That's why we have two hypotheses, null hypothesis and alternative hypothesis. Then the next one, this assumption may or may not be true. This assumption may or may not be true. That's why we are doing this research. Sometimes the research results may support the null hypothesis, or the research results may support the alternative hypothesis. If it is alternative hypothesis true, that is good for the researcher, because researcher is doing to fill some gap. That's why he is doing that research. Then if there is no gap, no need to do such kind of researches. Actually, we don't know whether we need to do this kind of researches or not. Actually, the validity of the research we need to find with the use of hypothesis testing. Then therefore, the assumption or the hypothesis may or may not be true. That is one concept of hypothesis testing. Yes, earlier also I mentioned you, we need to get the sample data for the research. We need to gather the sample out of the population and we need to get the data for the sample. Then therefore, it is impractical to use population data for large populations. That is another concept of hypothesis testing. Otherwise, we are not doing this kind of hypothesis testing. If we have uh, small population data, no need to do the statistic. But for the large populations, there are a large number of individuals. It is very difficult to get the data for the large populations. Therefore, we have to get the sample out and we have to do the research with the sample. That's the thing earlier also I mentioned you. We have to get the random sample out of the population to gather some particular conclusion or inference for the population. Then researchers typically examine a random sample from the population, I told you. Then we have to gather the random sample from the population when testing the hypothesis. Then actually that is very important thing. The thing is we have to get the random sample from the population. Get a random sample from the population. Then the basic logic of hypothesis testing is to prove or disprove the research question. Then the research title. Then we can prove the research title is true or not true. That's the thing we are doing under the hypothesis testing. Then we'll go to the steps in hypothesis. At very beginning also I told you, if you are learning hypothesis testing with the use of steps, that is very easy to learn. No? Then we'll go to the very first step, step 1. Step 1 is then making assumptions. Then which kind of assumptions? We have to gather the random sample. No, I told you earlier. Then actually we have to assume we are getting random sample. Another one is the data set should be normally distributed. Normally distributed data set. That is the step 1. We'll go in step 2, alpha level. Actually, what is alpha level? Alpha level is the probability. Alpha level is the probability that we reject null hypothesis. That we reject null hypothesis. Then there are some percentages to reject null hypothesis. Then 5% mean 5% probability is there to reject null hypothesis. 1% mean 1% of probability is there to reject null hypothesis. Then here you can see this area is the fail to reject null hypothesis. That means we have to accept the null hypothesis, that area. This area is the null hypothesis reject area. Null hypothesis reject area. Then this null hypothesis reject area will start with the critical value. Then that is very important value, critical value in the plus side and the minus side. Then here confidence intervals. Confidence intervals. Then alpha level is there in the both side. Then if it is 5%, what we need to do? 5 divided by 2. 5 divided by 2, because both areas we need to consider. Then confidence interval, confidence levels may be 90%. If it is 90%, confidence is there to fail to reject null hypothesis or accept null hypothesis. We have to reject null hypothesis. That probability is 10%. Then both side 5%. Then one side 5%. The other side also 5%. Like that. Then if we convert these values into set values, that is 1.645 critical value is there. Then 95% confidence level mean what? Actually, that is the 95% probability is there to happen or they are to accept null hypothesis. That means fail to reject null hypothesis. There is 95% of chance to accept null hypothesis, this area. Then if that's so, in the rejection area, the probability in the rejection area is the 5%. What is the meaning of 5% here? There is 5% probability to reject the null hypothesis. If we consider the both side, one side is alpha divided by 2, then 2.5 in one side and other side 2.5. Then if we consider the critical value for the 5% probability level for the alpha, that is 1.96. Then we'll go to 99% significant level or confidence level. The meaning is what? 99% confidence is there or probability is there to happen null hypothesis. That means correct the null hypothesis or fail to reject the null hypothesis. If that's so, there is 1% or 1% probability of chance to reject null hypothesis. That is, if we are getting the both side, the one side is 0.5% and critical value or said level is the 2.576. Like that, you have to know what are the probabilities to happen null hypothesis or not happen null hypothesis. Step 2, specify the null hypothesis H0 and the alternative hypothesis H1. Then null hypothesis would be H0 mu minus mu naught equals 0. That means H0 mu equal mu naught. That means there is no difference between two mean values. Then mu is the population mean or mu naught is the mean for the entire data for the sample. The sample value and the population value. Then null hypothesis means there is no difference in the population mean and the sample mean. If we reduce from population mean, the sample mean, we are getting 0. That is, there is no difference between population mean and the sample mean. That is called null hypothesis. Then we will set the null hypothesis. Then mu equal mu naught. Then there is no difference. Then we will get one example. Then here you need to consider. Normal population. The normal population is the mu. Then marks getting from the students without going to after school classes. Then we guess that that is one value, 1 marks, some particular marks. That is called mu. Then mu naught is we are getting the sample out of the normal population and we are the particular students are going to the after school classes. Then we can check those after keeping the test, we are getting the marks. Then that is called mu naught, that is sample data. Then what are doing ultimately? We are checking whether the mu equal mu naught or mu not equal mu naught. But in the null hypothesis, we expect mu equal to mu naught or otherwise. Then if we are checking the normal population, then marks getting from the students without going to after school classes are not have any differences of the marks getting from the students who go to after school classes. Like that, there are two values there. Then the alternative hypothesis would be H1 or HA, mu not equal to mu naught. Mu not equal to mu naught. Mu not equal to mu naught. The meaning is there is a significant difference between two mean values. That means marks getting from the students without going to after school classes from the normal population is not similar to marks getting from the students who go to after school classes. Those are uh, different. That difference is the significant difference between the two mean values. That is called alternative hypothesis. We'll go to the step 3. Then step 3 is the select in the sampling distribution. Select in the sampling distribution and specify the test statistic. Then here there are three type of test: one sample or two sample test, one tailed or two tailed test, set test or t-test. Like that we have to learn these different kind of test. Then one sample test we can consider, or two sample test we can consider, or one tailed test or two tailed test we can consider. We need to consider the set test or t-test according to the types. Under this course, we only consider the one sample test, not the two sample test for this hypothesis testing. Therefore, one sample test, there we are getting one tail test or one-sided test. Then one tail test or one-sided test also, there are two types: one-sided lower tail, one-sided upper tail. If it is the tail is in the left side, it is called lower tail or left tail. Then the tail is in the upper side, that is called right tail, right side. That is the upper tail alternative and lower tail alternative. That meaning is the critical region or null hypothesis rejection area in the left side, that is called lower tail. Then null hypothesis rejection area or critical region is in the right side, that is called upper tail. Now we'll go to one-sided lower tail or left tail alternative. Then actually left mean left side. The left tail is, this particular tail is the left tail. It is known as lower tail also. Then why it is called lower tail? Because here we are going to check whether the population parameter is less than some value. That is the alternative hypothesis. Then population parameter mean population mean is less than the particular value according to the research. Then the hypothesis for this testing can be written as follows. Then we can write the hypothesis, null hypothesis and alternative hypothesis. Then I told you the alternative hypothesis is the population parameter is less than some particular value. Then population parameter mean population mean is less than some particular value. Then we can set now null hypothesis. Then opposite of the alternative hypothesis. That is, the population parameter is higher than or equal to the particular value. Then if after finding the set test, then if we are getting the particular value less than the critical value minus 1.645, then what we can get the conclusion, then we need to reject the null hypothesis. Reject null hypothesis means we need to accept what? The population parameter is less than some value. That is the conclusion. Then if the particular set value fall inside this acceptance region, that means null hypothesis acceptance region, then we have to accept the null hypothesis. The meaning is the population mean is higher than or equal to the particular value, like that. Then we can express this by using calculation. We'll see now. We'll get one example. A company has replaced its original technology of producing electric bulbs by CFL technology. Earlier, the bulb was produced with the original technology. Now, the bulb is produced by the CFL technology. Then the company manager wants to compare the average life of these bulbs manufactured by original technology and new technology CFL. Then what we need to do, now we know the comparison, then write appropriate null and alternative hypothesis, also say about one-tail test. Then here you need to understand what is the one we have to take as the population mean. Then population mean we have to take as original technology. The average life of bulb manufactured by original technology, and the sample mean we have to take from the average life of bulbs with the new technology CFL. Now then you can see, then here I mentioned you the suppose the average lives of original bulb is mu1 and CFL technology bulb is mu2. Like that, you need to get idea. Then mu1 is the population mean, then mu2 is the sample mean. Then how can set the lower tail alternative here? Actually, if we set alternative hypothesis as, then the average life of bulbs which producing with the original technology is less than the average life of the bulbs with the CFL technology. Then because of this less than, it should go to the lower tail or left tail. That's the thing you need to understand. That one you have to take with the use of alternative hypothesis. How we can set alternative hypothesis with the population mean. Then you can get population mean is less than the sample mean. Then with that situation, it should go to the lower tail. Then if we set alternative hypothesis, the population mean is less than the sample mean, we have to set null hypothesis, that average life of bulb with the original technology is higher than or equal to the average life of bulb with the new technology. That is the setting of alternative and null hypothesis with the one-sided lower tail alternative. Then actually again I can explain for you. Since alternative hypothesis is left-tailed, therefore corresponding test will be left-tailed test, because it shows the average life of bulb with original technology is lower than the average life of bulb with CFL technology. That is the alternative hypothesis. Because of this less than, it is going to lower tail. Then we have to reject null hypothesis if the set test value is somewhere in the critical region. That means if it is less than the critical value 1 point minus 1.645, we need to reject the null hypothesis. That means we have to accept the alternative hypothesis. That's the thing mentioned here. Then if the set test value is somewhere here higher than minus 1.645, that means it is uh, related to null hypothesis acceptance region. Then at the time what we need to do, we need to accept the null hypothesis. That means fail to reject the null hypothesis. Then we need to reject the alternative hypothesis. That means then average life of CFL technology bulb is less than or equal to what? The average life of the bulbs with the original technology. We'll go to one-sided upper tail or right tail alternative then. Then actually right tail test is known as upper tail test also. Right tail. Then right tail is going to the left, right side, no? Right side. Then this test is used to check whether the population parameter is greater than some value. Then earlier one we checked in the lower tail one, the population parameter is less than some value, no? Then here we need to check whether the population parameter is greater than the given value. Then we'll set now null and alternative hypothesis. We'll set first alternative hypothesis. The population parameter, that means population mean, is higher than the given value. Then we can set now null hypothesis, that is opposite of alternative hypothesis. The population parameter is less than or equal to the given value. Then if the test statistic has a greater value than the critical value plus 1.645, what is the meaning? We have to reject the null hypothesis. That means we have to accept the alternative hypothesis. Then if the value is there with the less than the critical value, we need to accept the null hypothesis. That means we fail to reject null hypothesis. That means we need to accept the null hypothesis. Then to understand further, we'll go to this sum. Then suppose it is found that average weight of a potato was 50 gram and standard deviation was 5.1 gram nearly 5 years ago. We want to test that due to advancement in agricultural technology, the average weight of a potato has been increased. To test this, a random sample of 50 potatoes is taken and calculate the sample mean as 52 gram. Describe the procedure to carry out this test. Now we need to understand which kind of test, upper tail test or lower tail test. Now you know, then population average, population mean weight is 50 gram. Then after doing the research, then for the sample data for the 50 potatoes, uh, the sample mean is taken as 52 gram. That means it is higher than average. It is higher than average. Then it is higher than average mean, then alternative hypothesis is higher than average. That means it is upper tail test. We need to understand that is upper tail test because the sample mean is higher than the population mean. Then we can set hypothesis, null hypothesis and alternative hypothesis. Then go to the alternative hypothesis. Then alternative hypothesis is mu higher than 50 gram. Mu higher than 50 gram. That is higher than mean it is going to right side. It is going to right side. Then mu, we can set the null hypothesis, that is opposite of alternative hypothesis, mu equal or less than 50 gram. That is the null hypothesis. Then we'll go to the two-sided, two-tail alternatives. Then two-tail mean there are two tails there. Then one tail is in the left side, other tail is in the right side. Then there are two critical regions then. In the left side, one critical region and right side, other critical region. Then this is called non-directional hypothesis testing method. Then actually here we are going to check the alternative hypothesis. The population parameter is not equal to the given value. Okay, then some value. Then this is called two-sided, two-tail alternative. Then if we set null hypothesis, the population parameter is not equal to the sum value or the given value. Null hypothesis can be rejected if the z-test value is less than 1.96 and higher than 1.96. Then those areas are called critical regions. Then those areas we can reject the null hypothesis. If the z-test value is somewhere in the null hypothesis acceptance area or fail to reject null hypothesis if the z-test value is somewhere here in this area. Then when we set the hypothesis, then alternative hypothesis is mu not equal to mu naught. And null hypothesis is mu equal to mu naught. Then if the z-test values are in the critical region, the meaning is what? We need to reject null hypothesis and we need to accept the alternative hypothesis. Then that is third step I explained you. Now we will go to the step 4. Step 4 is the finding the test statistic. Then how can find this test statistic? We have to use this equation. Z equal x bar minus mu naught divided by sigma divided by square root of n. This is the equation to find the test statistic. That means Z value with the calculation. Then step 5. What is the step 5? Making a decision and interpreting the results. Then if the z-test value is higher than the critical value, we need to reject null hypothesis. Then that means if the z-test value is in the critical region, we need to reject null hypothesis. Earlier also I mentioned. Then if the z-test value is less than the critical value, we fail to reject null hypothesis. That means we have to accept the null hypothesis. That is step 5. Then we will go to one example. The average yield of cabbage is 1000 kilogram. That is the population mean actually. Assume that the population is normally distributed. A farmer is concerned that the true mean is actually higher than this. Farmer is guessing the true mean should be higher than this. He randomly selected 49 samples and calculated a sample mean of 1150. Assuming that the standard deviation of cabbage yield is 700 and set alpha as 0.05, test the alternative hypothesis true or false. Then we will see how can now we will go to the first step. What is the first step? Then first step is we have to assume what? A random sample, normally distributed sample. Then here it is mentioned normally distributed. Assume that the population is normally distributed. One assumption is there. And he randomly select 49 samples. Randomly selected samples are there. Therefore, you can get these two assumptions as step 1, a random sample, normally distributed population. Normally distributed population. We'll go to step 2. That is the set null and alternative hypothesis. Then we can get null alternative hypothesis first. Alternative hypothesis first. Then alternative hypothesis, it is mentioned. The farmer concerned, the true mean is actually higher than this. That means higher than 1000. True mean should be higher than 1000. Then we have to set opposite of the alternative hypothesis for the null hypothesis. Mu is less than or equal to 1000. Then alpha level is 0.05. We are checking this at the alpha level of 0.05. That is the step 2. Then step 3, selecting the sample distribution, sampling distribution and specify the test statistic. For that we have to select the which kind of test. It is checking only one sample, then one sample, one-sided, upper tail and set test. We are using one sample test. One-sided test, that is upper tail test, because this alternative hypothesis we are going to check, it is higher than the population mean. We are going to check whether it is higher than the population mean. Therefore, that is upper tail test, and we are using the set test for the sum. Then step 4 is the calculate a test statistic. Then by using this equation we can calculate the test statistic. Then we'll do the calculation. X bar mean 1250 minus mu naught mean, population mean, that is 1000, divided by standard deviation is 700, and there are 49 samples there. Then we have to get the square root of 49 samples. Then ultimately we can get the answer as set 1.50. The next step is making a decision and interpreting the results. Now we can see then our results from the set test is 1.5. Then 1.5 is less than 1.645. Therefore, it is somewhere in the null hypothesis acceptance region. Thus, our test statistic is not in the null hypothesis rejection region. it is acceptance region, and therefore we fail to reject null hypothesis. Then that means the average yield of cabbage is 1000 kilogram or less than that and not exceeding 1000 kilogram. That is the answer. Then next example is, a person has interested to find in the mean height of a certain population. A random sample of 10 individuals drawn from the population of interest has a mean of 4.5 feet. Assuming that the population is approximately normally distributed with the variance of 4 feet and mean of 5 feet, test the hypothesis at 0.05 alpha level. Then what is the very first step? Making assumptions. Actually this is random samples. We are using the random sample and normally distributed population. Normally distributed population. That is step 1. Then we'll go to step 2. Then here a person has interested to find in the mean height of a certain population. Mean height of a certain population. Then is doing some particular research by using random sample, and he got the sample mean of 4.5 feet. Then assuming that the population is approximately normally distributed with the variance of 4 feet and mean of 5 feet. That is the population mean. Population mean is the 5 feet. Then what we need to do, we need to check whether the population mean is 5 or not 5 feet. Okay. Then alternative hypothesis is the population mean is not 5 feet. Then null hypothesis is then population mean is equal to 5 feet. Then we need to check what is the test we need to do. Then this is actually equal, not equal, like that we are setting the null hypothesis and alternative hypothesis. That is two-tailed alternative Z test. Two-tailed alternative Z test. The next one is we need to test the statistic. We need to test the statistic. For that we need to use this equation. Then calculations we have to do. 4.5 is the sample mean minus population mean 5 divided by, then here it is given what? Variance. It is given the variance. Then we have to get the square root of variance is the standard deviation. We have to find the standard deviation with the square root of variance. Then divided by square root of 10. Then ultimately you are getting the answer 0.775. Then we will check the results, interpreting the results. Then Z value is minus 1.96. Then what we can tell here, then minus 0.77 is higher than the table Z value or critical value minus 1.96. Therefore, it is very difficult to reject H0 mean null hypothesis. It is very difficult to reject null hypothesis because it is a null hypothesis acceptance area. The Z test value is null hypothesis acceptance area. Then therefore fail to reject null hypothesis. That means we have to accept the null hypothesis. That means there is no significant difference of the sample mean and the population mean. That is the answer for this particular sum. I think you can understand the hypothesis testing. Actually, if you are following this video very slowly, you can understand everything.